So what was the point of this dot product? That are a few different points with the dot product, but as you saw, when I had two vectors being perpendicular, you got 0 as the dot product. Here we have, I mean, what does it mean for two vectors to be perpendicular? It means that the angle between them is pi half, right? 90 degrees. So so we have to carefully define what we mean by the angle between two vectors. So here we have two vectors, right? What does it mean to have an angle between them? So an angle between two vectors is a number which we require to be between 0 and pi. And the reason for this is that pi, which is 180 degrees, right, is sort of as far away two vectors can point from each other. If you take it bigger than that, they start getting closer on the other side, right? So you don't have a sign on this angle when you talk about the angle between two vectors. Then you say that A and B are perpendicular if the angle is pi half. You say they are parallel if the angle is 0 or pi. So if they point in the same direction or the opposite direction. And by convention, the 0 vector is both perpendicular and parallel to any vector. We talked about this earlier, but it turns out that the right way of defining these things is to say that the 0 vector has any and all directions at the same time. So it's probably easier to see the angle if I do something like this. So you can see there's an angle theta down here, right? I can try. Sorry, it's a bit hard because there are too many dimensions to keep track of. But if I had more luck than I have right now, I think this one is stuck. I would be able to show you that if the angle sort of gets bigger than pi, then it would flip, and this angle thing would be measured on the other side. Yeah. So what does that have to do with dot products? Well, we have the following theorem. So if theta is the angle between vector A and vector B, then it turns out that the dot product of A and B is equal to the length of one vector times the length of the other vector times cosine of the angle between them. So that's what I said, that if you scale one vector, I doubled the length of the vector on the previous page. And what happened was that the dot product also doubled, right? This is reflected in this fact. If you double the length, you also double the dot product. And then you see that cosine of the angle enters here. So cosine of 0 is 1, right? And cosine of pi is -1, right? So if you have two vectors pointing in the same or the opposite directions, basically you get the product of the two lengths and then with the sign indicating whether you are in the same direction or the opposite direction. And what is cosine of pi half? It's 0, right? So no matter how long these vectors are, you will multiply by a 0 here if the angle is pi half. So if you have perpendicular vectors. This result means that we can actually find cosine of an angle. And this is very neat, because if you have cosine of the angle, you can also find the angle, because you know that the angle is between 0 and pi. How do you do that? Well, you just divide by these two lengths on both sides of the equation, and then you end up with this equality. Cosine of the angle between the vectors equals the dot product divided by their lengths. So here we have an example. We have some vectors. I played around with them before. For some reason, this one got stuck before because it's behind this text object. But you can see Now the angle is close to pi half, right? And the product here, the dot product, is very small. Now they are close to being pointing in opposite directions, and this becomes a large negative number, relatively large negative number. So that's how they behave. Then we have this theorem. If, this is what I already mentioned, if A and B are perpendicular, A and B are perpendicular, if and only if the dot product is 0. So to prove this, we just say that, well, if the dot product is 0, then this product is 0. But if this product is 0, then at least one of these factors have to be 0. So either the length of A is 0, or the length of B is 0, or cosine of theta is 0. And when I say or, it's always in mathematics non-exclusive or, so you can have that more than one of them are 0. But in all cases, this can be rephrased in the following form. Either A is the 0 vector, or B is the 0 vector, or the angle is pi half. But by this convention over here, 0 is both perpendicular and parallel to any vector. So in particular, if one of them is the 0 vector, then they are perpendicular. And if none of them are the 0 vector, then we know that the angle between them is pi half.